Hey guys, welcome back to another episode of the Coffee Course, and today we're taking a bit more of a deep dive into some of the science behind espresso. I'm joined once again by Tom from Pangea Coffee Culture. Tom?
Hey Jeff, how are you?
I'm good. So you've been putting together a bit of detail for the guys, and you're going to take us through some talk about espresso baskets, right?
Yeah, we're going to do our first episode on espresso as a part of the kind of espresso series, and we're going to talk about baskets and tampers today.
Great. So let's dive into it.
So we're going to start with baskets and tampers today, Jeff. So between kind of accumulating the knowledge that I already have and kind of doing a little bit more online research, I've kind of put together a little bit of an illustration that you can see now on screen about tampers. And obviously you and I know a lot about tampers and baskets. So what are they? So baskets, tampers, something we'd be really familiar with. For some people out there at home, they might not know a lot about espresso equipment, so we're just going to break it down a little bit. Basically, baskets are the hand containers the coffee is grinded into for brewing espresso. And the tamper then is the tool for compressing the grinded coffee together. And both of these tools must fit together like Lego, otherwise you get an uneven extraction, and we're going to show you why. So on screen at the moment, I drew out three different baskets. The first basket is a basket that you might see that might come stock with your espresso machine. It has curved sides. As you can see, they're kind of like 70-degree angles at either side. And it's usually a 58.4 millimeter basket. The second one then it would be like a single espresso basket that we would never see in specialty coffee, but we might see it in some, regular coffee shops, or they still use it a lot in Italy or continental Europe. They usually hold about 8 to 10 grams. And then the third one is, I think you have them, Jeff. They're called like VST baskets. That is one of the companies.
Yeah, something we changed over to pretty much straight away upon opening.
They're great. And you would have started obviously with basket number one there with the curved
Yes,
sides.
that would have been what would have come with our machine from the manufacturer.
As you can see in the third illustration, they have the sides are just straight down. They're just they're 90 degrees to the horizontal line, so they just go straight down. And this plays a massive part because, as you can see, I've done out kind of the red zones is basically where when you dose coffee grinds together and they compress, they'll come to an ultimate compression limit, and that is because as the coffee is compressed further down, it stops because it reaches this ultimate compression, and it's not because the coffee is pushed to its ultimate limits, it's because the sides have come in, have caved in basically, and it doesn't allow the coffee to compress anymore. It's the same in number two. The coffee at the sides, it only, in illustration number two, it compresses to a maximum, and then the coffee in the middle isn't compressed the same as the outside coffee grinds. So that's why we'd use VST baskets, and as shown in number three, there's nothing stopping it, only the coffee. The downward force is only due to the upward force of the compression of the coffee. It's not got to do with how the walls are caving in like in 1 and 2. In illustration number 1, we said that it's approximately 58.4, but illustration number 3, nearly always 58.4 with VST baskets, and that's because the tampers have to fit exactly into them. With the tampers then, a lot of coffee shops, to combat the difference in compression in, let's say, number 1, tampers would use curved edges. Like the first tamper I drew there that has, in the first illustration, they have curved edges, and this reduces the amount of pressure on the sides because the coffee on the sides would be compressed more than the middle. So in the tamper number 2 illustration, the 58.4 plus or minus 0.05 millimeters, you'll see that tamps right into the corners of the VST baskets. So as a kind of a microscopic look at the tamper number 1, you can see the corners are curved, and this is to basically decrease the amount of pressure on the sides of the basket that you would see in number 1. We've got a little mini illustration by how much it can be out by and how this is affected throughout the whole basket. So when we're talking about millimeters here, but because it's an area, the millimeters are going to be, as we'll see later on, is going to be squared because it's an area. We'll show you the maths on that later. So we're going to take a little microscopic look of what's happening to the tamper that you normally use in your coffee shop. So this tamper is usually about 58 millimeters. Your basket then is usually about 58.4 millimeters. So there's a 0.4 of a millimeter you're off by already from the tamper to the edge of the basket. You can kind of see this when you play with the tamper. There's that little bit of movement back and forth, that kind of clicking as you move it. And you may think that's not important, but actually it's pretty important. Also, if you don't have a completely flat tamper and you've got the curved edges like you see in the first tamper there, the 58 millimeter one, that's also going to add another kind of negative to your tamping. So first off, we have the 0.4 of a difference between the basket wall and the side of the tamper, 0.4 millimeters there. And then we have, because the curved edge is there, you're actually adding on another millimeter there of non-contact between the tamper and the coffee. And that's massively affecting your extraction, because the contact isn't there to compress the coffee. And when we see in a little bit of the equations later, it plays a massive part when you're talking about overall area. It may just look like a millimeter and 0.4 of a millimeter, but overall it adds, it's a massive difference. We're going to go back to a little bit of junior cert maths. We're just going to look at a little bit about area. When we're talking about area, we're talking about of the total amount of area on the top of the basket, and we're going to look at the total amount of area your tamper has. And we want these to be exactly or as close to 100%. So total coverage of the tamper and total coverage of your basket area to tamp down, to get a perfect extraction. So I drew up basically two areas. I did the area of the VST basket, which is the number 3 there, the orange illustration. And we just did out a basic equation. Area is equal to pi r squared. So it's 58.4 millimeters is the diameter, and we just divided that by 2 to get the radius, and we squared it. This will all kind of make sense in a couple of seconds. So the total area of your VST basket, so the basket you want to, the most perfect basket you could say, is 2,678.6 millimeters squared. And then also I did out the area of the tamper you would have in your regular coffee shop. So your normal 58 millimeter tamper with your 0.4 and 1 millimeter off. I just did out the area there. The area of this tamper is pi by r squared. So it's 58 millimeters minus your 1 millimeter minus your 0.4 millimeters, and then you divide it by 2, and that gives you your 27.6 squared. And that total area comes to roughly 2,393 millimeters. So I know that doesn't seem like a whole pile. It's actually 3 centimeters squared worth of
surface area.
Of surface area, yeah. So you're actually only, if you're using a VST basket and your normal 58 millimeter tamper, Jeff, you're actually only covering 89% of your basket. So 11% of your basket still needs to be compressed to the perfect compression. And yeah.
And I guess if you said to someone that there was a way for you to make sure that their coffee was 11% better every time, they'd probably take that,
100%. And it's just another thing for us to lock down. We've got so many variables in espresso, and this is one thing that is so easy just to get right, because you can just buy the equipment. You can just get some VST baskets and get a 58.4 millimeter tamper. There's plenty of them out there. They're really well made.
We made this change not long after we opened. We changed our baskets and our tamper, and even the tamper that we got wasn't the traditional push tamper. It's the ones with the lock in it, so that. And you've worked for me occasionally in the shop, and there's obviously quite a big physical difference in size between us, but because it's restricted in how far it can push down, once you find the right setting for that, that's another area of consistency. So whether it's me or you or someone else who makes that coffee, as long as we've weighed it and dosed it correctly and we're using these tools, you're going to get the exact same product from all of us.
Exactly. Humans are inconsistent, so
we're the biggest variable in this whole output.
By a mile, by a long shot. Yeah. We're going to talk about automation in coffee, maybe after the Espresso series is done, and how it's important for us to really, because this looks like it's all going to be mechanized in a really, really quality system. You and me really need to be working on our palates more so than anything, because we still have to be able to find the recipes for these and adjust the systems how we want them. So yeah, it's just always about reducing variables, decreasing that error that humans always have, you know.
And I guess this in some way stems back to something you mentioned in the introduction of the last episode about how a lot of people are under the impression that coffee is art, but really it's more science based. And this is clear evidence that science is a very important aspect of it. But once you get this working and you can dial in and be consistent in how you work, and then follow along with some consistency on your taste and your palate, so you know when you've hit a problem, that's when then you can go into more interpretive areas and take your own spin and change things. But at least you know you're starting from a solid base, so you know where to expect those variations.
Exactly. I couldn't have said it better. Yeah.
I think that's probably a lot of stuff for people to process. I mean, for those of us who work in the industry day to day, these diagrams make more sense. We're looking at these products, you know, we've seen how they fit into the group heads, how the difference is. And one of the best ways I think of evidencing it is after you've made a shot of coffee and you knock it out into your basket, you can see when you've used a VST basket how much more compressed the coffee puck is and how much more consistent it looks as opposed to ones coming out of the other baskets that sometimes be a bit softer or maybe fall apart on one side. So I guess if you're in a coffee shop, keep an eye out for that. Watch the coffee pucks that are coming out into the tray and see what you're expecting.
Yeah, exactly. Yeah, look, and even break them apart. See where the coffee flow is going through. Coffee's like, or water is like electricity. It's going to go from point A to point B in the shortest amount of time. So if you've got compression in one place and different compression in another, it's going to flow through the easiest path. So don't be afraid to, break open your pucks, see what's in them, see where it's dry patches, wet patches,
and learn from there.
Yeah.
Okay, so I think that's probably all we have for today, Tom. Thanks for taking the time to put together the drawings and for joining me on the phone. I'm sure, as ever, if anyone has any questions, they should feel free to get in touch.
Exactly, yeah.
So I will look forward to talking to you next week when we'll probably be talking on some more espresso-related topics.
Yeah, and we're also going to keep going with espresso. We're going to look a little bit of how to make your own homemade water as well, which would be good fun in a couple of weeks.
So, guys, I've been Jeff from Tree Bark Store.
And I'm Tom from Pangea Coffee Emporium.
Thanks, guys.
Thanks, guys.